A container of an ideal monatomic gas has a movable piston that allows the volume of gas to change without allowing any gas particles to enter or leave the container. The container is made of a conductive material that allows heat to flow in or out of the gas. So on our image here, we can see that conductive container with a gas inside and a piston that moves up and down. Our goal is going to be figuring out what's happening to the internal energy of the gas, the heat flow, and the work done. Here we have our equation for the first law of thermodynamics. It says delta U equals Q plus W. U is the internal energy of our gas. For an ideal gas, the internal energy is equal to the kinetic energy of the particles in that gas. So that's essentially how much energy our gas has. Then we have Q. Q is the heat that flows into our gas. Then we have Q. Q is heat, in other words, thermal energy. Heat can either be added to a gas, which is positive heat, or it can be removed from a gas, which is negative heat. And then we have W, which is work. Work is a transfer of mechanical energy between systems. For example, moving the piston would be an example of mechanical energy. And we're told that work done on a gas by the surroundings is defined as positive, and work done on the surroundings by a gas is defined as negative. So that's our important equation. Delta U equals Q plus W. In other words, the change in the internal energy of the gas is equal to the heat that flows into the gas plus the work done on the gas. So now we'll go ahead and read through the description of what happens in this process, and we're going to start to fill out our list of variables here. First, we're told the initial internal energy of the gas is 536 joules. That's going to be UI, the internal energy initial. So we can fill that out there. Next, it says that during a thermodynamic process, 349 joules of work is done on the gas by the piston. Now, to remind ourselves, work done on the gas is defined as positive. So that means we're going to have positive 349 joules of work, because that's work done on the gas by the piston, which we can see here. The piston pushes in on the gas, doing work on it. So our work done is going to be 349. We're also told 134 joules of heat is removed from the gas. So heat added to the gas is defined as positive. Heat removed from the gas would be defined as negative. So we've got 134 joules of heat removed. That means our Q, our heat, is going to be negative 134. Awesome. So we now know Q, heat, is negative 134. W, work, is positive 349. So to find our change in the internal energy, we're going to put that into our equation. Delta U equals Q plus W. Our unknown is delta U, so that's already arranged correctly. We just need to go ahead and put in our numbers. So delta U is equal to Q, which was negative 134, plus W, which was positive 349. If we put that into our calculator, we're going to get a value for the change in the internal energy of positive 215 joules. So we can go ahead and fill that in. Delta U is positive 215. Awesome. Our last thing to fill out here is our final internal energy. So the change in internal energy, delta U, is found by doing our final energy, UF, minus our initial energy, UI. So that's our equation we're going to be using here. Now we need to find UF. So we want to rearrange to get UF on its own. I'm going to add UI on both sides so that it will cancel out on the right-hand side. And we're just left with UF is equal to delta U plus UI. So we can go ahead and put our numbers in there. Delta U is 215 plus UI, which is 536. So that gets us a UF, a final internal energy, of 751 joules. So we can go ahead and fill in the answer here. Our final internal energy is 751 joules. Now we can go ahead and answer these 3 descriptive questions explaining what's happened. So firstly, to describe the change in the internal energy of the gas. Well, we know our delta U was positive. That means we had a positive change in energy. And we can see that as well from our UI, our initial, to our UF, our final, the energy increased. So the internal energy of the gas increased in this situation. In terms of heat flow, we had negative 134 for our Q, our heat. So that means heat flowed out of the gas. So heat was removed from the gas. As for W, work, that's a positive number. That means that work was done on the gas by the piston. So you can see here the meaning that the positive and negative signs have for each of our symbols. So both work done on the gas and heat added to the gas are positive and will increase our overall internal energy, whereas work done by the gas and heat removed from the gas are both negative values that will decrease our internal energy. Let's do one more question of this type. In this question, during a thermodynamic process, 399 joules of work is done on the piston by the gas. Now we know that work done on the gas is defined as positive. So work done on the piston by the gas, that's going to be negative. So we're going to go ahead and fill in that for our W, which is the work, is going to be negative 399. That shows that energy is removed from the system. Then we're told 149 joules of heat is added to the gas. That's our Q. Heat added to the gas is defined as positive. So our Q, our heat, is going to be positive 149. The positive shows energy was added. Then we're told the final internal energy of the gas is 430 joules. So we can go ahead and fill that in for our final internal energy, UF. That's 430. So we know Q and we know W. We can use that to find delta U, the change in internal energy of our gas. Our equation is already arranged for delta U equals Q plus W. So we'll just put in our numbers. Q is 149 plus W, which is negative 399. If we put those numbers into our calculator, we will get a value for the change in energy of negative 250. So we can go ahead and fill that in here. For delta U, it's negative 250. Then we can use that in our change in internal energy equation, which is the final energy minus the initial energy, in order to figure out our initial energy. First, I'm going to rearrange this equation for initial energy. Right now, I have minus UI on the right-hand side. So I'm going to add UI to both sides of my equation so that the UIs will cancel out on the right-hand side. And I'm left with a positive UI on the left. Then I'm going to subtract delta U from both sides of my equation so that that will cancel out on the left side of my equation. And I'm just left with UI is equal to UF minus delta U. So we can go ahead and put our numbers to that. UF is 430 minus delta U, which was negative 250. So putting that into my calculator gets me an initial internal energy of 680 joules. So we can go ahead and fill that in the UI box. That makes sense because our energy change was negative, so our initial energy has to be higher than our final energy. Okay, great. Finally, we'll fill in these sentences below to describe what happened. In terms of the internal energy, delta U was negative, showing that our internal energy decreased. For heat flow, Q is a positive number here, which means heat was added to the gas. For the work done, we had a negative value. That means work was done by the gas on the piston, which removed energy from the system. So work was done on the piston by the gas.